Welcome to Braille Institute. Now we are discussing the geometric distribution. So this geometric distribution is under the Bernoulli's trial. So this also we indicated Bernoulli's trial. So Bernoulli's trial is required. We know the Bernoulli's trial. We can check with some example. So this is a dice. I am throwing this dice. So this dice I am throwing. So dice, what is the particularity? Dice will be a 6 face. 1 dot, 2 dot face is there, 3 dot face is there, 4 dot face, and 5 dot face, and 6 dot face. So like this 6 score is there. Score we can write is a 1 score, 2 score, like that. So this dice I throwed. So dice I throwed. So I have a outcome. What is my outcome? Outcome I defining like a success or failure. So that is a Bernoulli's theorem. So this here in Bernoulli's I defined it is a score 6. Score 6 means my success. So here is a success and here it is a failure. So what are the possible outcomes? S in the sample space I can define the sample space. It will be a 1 or 2 or 3 or 4 or score will be a 5 or score will be a 6. When I will become 6, if I get a 6, I am a success. So what is the percentage of success? Success we can write it is a P is equal to 1 by 6. Failure is equal to 1 minus P is equal to 5 by 6. So what are the scores are failure? 1, 2, 3, 4, 5. These all scores are failure. If it is a 6, I am success. So this is a Bernoulli's trial. In first trial, this is a particularity for the Bernoulli's trial. So all trials are independent. I am taking the first trial. First trial. So I throwed this dice. What happened? This dice I throwed. I got the number 1. Number 1. So that means I failed. I throwed this dice. In top it is showed number 1. That means this single dot. So I failed. Here I will write what I saw the first trial. It is a 1. I failed. So I throwed again. Next time. Second trial I throwed. I got the number 5. So again I failed. You see. So here I failed. Here also failed. I failed again. Because I got the number 6. I throwed again. Third trial I got the number 2. So that means I failed again. So in my sample space number 2. I failed again. Fourth time I am throwing again, fourth trial. So I got number 6. So I can say I success, become success. So here is it is 6. I become success. So in this geometric distribution is saying that it is a Bernoulli's trial. Each trial is doing the Bernoulli's trial until up to one first success. To reach up to first success. So we can define the X. X is defining number of trials required. Number of trials on which first success occurred. Success occurred. So number of trials is required on which the first success occurred. So here how many number of trials I taken? I taken 4 trials. I taken here is X is equal to 4 trials because first 3 trial was failed and fourth trial only success. So probability of S is equal to 4 is geometric distribution defining X is equal to X is defining P 1 minus P raised to S minus 1. So this X is equal to 1 or 2 or 3 or like that. P will be 0 and 1 in between the 0 to 1. This is S. So here P is equal to X is equal to 4. So what will get? 1 into 1 minus P raised to 3. So here we can call this S minus 1. Here this S minus 1 we can call S minus 1 is equal to number of failures. S minus 1 is equal to number of failure. So this is the geometric distribution. Geometric distribution, we are doing the Bernoulli's trial. Each time we doing the Bernoulli's trial and we are defining the S. S is defining the number of trials on which the first success occurred. First success. Here we have done the first trial, it is failed. Second trial, it is failed. Third trial is failed, and we fourth trial becomes success. So we taken the fourth trial, probability of x is equal to 4 trial. It is, you can write this like that, probability p is to 1 minus p raised to 3. Here this one is equal to p is equal to 1 by 6. P is equal to 1 by 6. You can give the 1 by 6. Here is 1 minus p means 5 by 6. So this is the answer. Now, why it is called the geometric distribution? We can check how it is become the geometric distribution. Now you can check each one. Each one we can check. In the first trial, now is doing the first trial. So this is a same case I am considering. In the first trial itself, it is success. This first trial I got the number 6. So what will happen? My first trial itself is success. So I can write a probability of s is equal to, this is 4. I can write here, I am writing probability of here I'll write probability of x is equal to 1. First trial itself I am success is number 6. So what is my probability distribution? P into 1 minus p raised to 0. There is no failure. So I can write p is equal to 1 by 6. And this term is equal to 1. So we can remove this term. So this is a first trial itself. Success means s is equal to 1. I got the 1 by 6. I got the 1 by 6. Now you see, first trial was a failure, not a success. Second trial was success. Second trial was success. Second trial was success. Then what will be my figure? Second trial was success. So what will I can write the probability of s is equal to 2. If first trial was a failure and second trial was success. So in second case, other case, we are considering other case. Second trial was success. So what will be my probability? Here I can give p into 1 minus p raised to 1. S minus 1. So 2 minus 1, it is 1. So what is my probability? We can write it is p is equal to 1 by 6 and 1 minus p is equal to 5 by 6. So raised to 1. So we can remove this one. So it is a 1 by 6 into 5 by 6. In third case, we can consider another case. You see, this also failure. Something 3. In third case, we are taking the third trial. Third trial is become success. So what we can write the probability of x is equal to 3. That means we have a 2 failure and 1 success. So that also we can write p into 1 minus p raised to 2. 3 minus 1, 2. So that is a 1 by 6. This is a 1 by 6. This is a 5 by 6 raised to 2. So into 5 by 6 raised to 2. So we can write like that. Next case I am considering the fourth case. Fourth trial was success. So this was a failure. We can give some other number. So fourth trial was success. So what will happen? Probability of x is equal to 4. So this is a 1 by 6 into 5 by 6 all raised to 3. Now you see number of failure is coming like that. You see this distribution 1 by 6 and 1 by 6 into 1 by 6 into 5 by 6, and third case is 1 by 6 into 5 by 6 all square. On fourth case is 1 by 6 into 5 by 6 all raised to cube. It is going like that. In fifth case is correct means 1 by 6 and 5 by 6 raised to 4. So this is coming under the geometric progression. This you can see it is a geometric progression. That's why it is coming the geometric distribution. So in this geometric distribution, we studied that we have a x is the number of trials on which the first success occurs. So we checked the different cases where the first success occurred. Each case where the first success occurred. So we got the idea about the what is the geometric distribution. Now we'll move to the other case. Geometric distribution under conditional probability. Geometric distribution under the conditional probability. Conditional probability, how to write the conditional probability. Now here we have a n trials. We have done the n trials. We can write the, we have done the n number of trials. Number of trials. All are failure. All are failure. We have done the n number of trials. All are failure. Now they are asking, yes, additional number of trials is required. Additional number of trials is required to success, to become success. So there is some condition, n trials are failed and x additional trials are required for become success. So this condition, how to write this condition? You can write this condition. Probability of x is greater than x plus n. Probability of x additional trials is required. This one says a condition that s is greater than n. You see, s is greater than n. Number of trials, n trials are failed. Now they are asking how much additional, s additional trials are required for the success. So s is additional trials is required for the success, s plus n. So total s plus n trials under the s greater than n. Already s is success is greater than n only. So this is like a probability of a divided by b. So we can write it is a probability of a intersection b divided by probability of b. So we can write like that. So probability of a intersection b, in this case here it is s greater than n and s greater than s plus n. This s is a capital S. This is a capital S. S is greater than n and s is greater than s plus n. So this one you can write is a probability a intersection b. We can write probability of a intersection b. We can write as a probability of s greater than s plus n. So this is equivalent. S is greater than s plus n. We can take it because s is greater than n and s greater than s plus n. So a intersection b will be s greater than s. So this one we can write as like this formula. Probability of s is greater than s plus n, all divided by probability of s greater than n. S is greater than n. So it's a probability of b. Here it is a s greater than n. So we taken the down s greater than n. So s is greater than n. How to write this? We already studied the probability of s is equal to s. Probability of s is equal to probability distribution is a p into 1 minus p. P multiplied with 1 minus p raised to s minus 1. Distribution function CDF, cumulative distribution function is equal to, CDF is equal to, we can write cumulative distribution function is equal to, it is like 1 minus p raised to s. This is the cumulative distribution. 1 minus p raised to x. So here in this case, probability of s is greater than x. We can write 1 minus probability of s is greater than. So cumulative distribution we can write it is a probability of s is less than or equal to s. That will be 1 minus p raised to s. S is greater than s means 1 minus probability of s less than or equal to s. So this is equal to the 1 minus p raised to s. This is equal to the 1. So this 1 minus is taking inside, it will go like that everything, and it is become 1 minus p raised to s. So what will happen, this formula is become probability s is greater than s plus n. It is a 1 minus p raised to s plus n divided by s is greater than n. This is 1 minus p raised to n. So we can cut here, it will become 1 minus p raised to s. This is same equal to the probability s is greater than s. Equal to the probability of s is greater than s. So what we understood? This is equal to the probability of s greater than s. So this geometry distribution also we have some memoryless property. We can write this a memoryless property. memoryless property. We will call the memoryless property. What is the meaning of memoryless property? If you are n number of trials, we forget about the n number of trials. We don't have any memory. We already know this n number of trials is failed. You forget about the n number of fails. We are considering s additional trials is required. So what happened in previous case, we are not taking here. Now we are taking the same probability. Yes, is additional case. Number of additional case we are taking. That one only is considering for the probability. This old case, n number of trials is failed case we are not considering. That is why it is a memory less. That memory is gone. This one is not required. This memoryless property will study in the Poisson distribution. So that is a conditional distribution. It is showing some memoryless property. That means it is same like a S additional success. If you are calculating S additional success, we got the formula for the same. So this one is not at all important. What happened in the previous case? So that is the geometric distribution. We can one more way we can express this geometric distribution. This is a one method to express the geometric distribution. We can one more method we can apply for express the geometric distribution. Here you see, here we are studied the S is equal to number of trials on which first success is occurred. S is number of trials on which first success is occurred. So S will be S is equal to 1 trials or 2 trials or 3 trials, so it will go like that. We express it like that, and our probability distribution, probability of S is equal to S, it is a P and 1 minus P raised to S minus 1. This is my formula. Here S is number of trials on which first success is occurred. So my trials will be first one first. This may be x is equal to 1 means it is a success. S is equal to 2 means second one is success. First one is failed. This will be expressed still. Now second alternative expression. So there is a alternative expression. Y is the number of trials of failure. Number of trials of failure. So failure before the first success. Before first success. You see? Now this word is used before the first success. Y. Now is writing Y is the number of trials of failure before the first success. So what will be my formula? Here probability of Y is equal to Y. What will be my formula? Is equal to P 1 minus P raised to Y. It is only Y. This is not required S minus 1 because Y is equal to S minus 1. Here in this case we have a S minus 1 failure. Here you see S minus 1 means that is a failure. S minus 1 failure is there. Here Y itself we are saying that is a number of failures. So Y is equal to the S minus 1. Here what is will be my mu? Here this mu is equal to 1 by P and variance is equal to variance of S is equal to 1 minus P divided by P square. 1 minus P divided by P square. That is variance. Here in the second case, here we have to draw the first case and second case. In second expression, this is just a different expression, that's all. In second expression, what will be the my mu? Expectation of S, mu is equal to expectation of Y. Expectation of Y means it is expectation of S minus 1. So this is we can write 1 divided by P minus 1. So this is equal to 1 minus P divided by P. That is my moment. Moment is equal to expectation of Y. Here it is a Y, so we taken the expectation of Y. It is expectation of X minus 1. 1 by P minus 1 is equal to 1 minus P divided by P. So variance is same. Variance is same 1 minus P divided by P square. Variance is same for the both case. There is no change for the variance. Only expectation of here there is a change 1 minus P divided by P. We can take one more example for this alternative case. Not in the first case. For the alternative case we will take some example. In a call center, so many people are sitting and calling to people. And what will be my success? Success ratio. I am defining S is my success. I defining my random variable X. Number of calls, number of phone calls, number of phone calls failed, calls for failed, number of phone calls is failed before first success, before first success. So X I defined, number of phone calls is failed for before first success. X I defined number of phone calls is failed before the first success. And what is the success? Success ratio P is equal to, it is 0.1. So P is equal to 0.1 is the success ratio. Now they are asking about what is the probability of S is less than 8. What is the probability of S is less than 8? Less than 8, H is a failed, number of phone calls is failure. Number of phone calls is failed before first success. So here you just see it is a before first success. So number of failed, X means number of failed. So number of failed is less than 8. Probability of X is less than 8. What is the probability of X less than 8? What is the meaning of probability of X less than 8? It is a probability of S is equal to 0 plus probability of S is equal to 1 plus probability of S is equal to 2 plus up to probability of S is equal to 7. S is equal to less than 8 means here maybe first failed 0 and S is equal to 1, maybe S is equal to 2. In this case, Y will be, here you see, Y will start with 0, 1, 2, 3. It will like that. Because 0 failure will happen. That means the first call itself is success. 1 failure will happen. That means two trials will be there. So here you see S less than 8 means S will be 0, S will be 1. 0 means 0 failure, 0 failure. Here 1 failure, here 2 failure, up to 7 failure. What is the S less than 8? Here you see success is equal to P is equal to 0.1. What will be expectation of H? In second case is 1 minus P, 1 minus 0.1 divided by P 0.1. So 9 calls will be failed. P is equal to success means 0.1 means if you are calling 10 times, 10 calls, what is the meaning? 10 calls, 1 call only becomes success, 1 call may be a success. Success ratio is equal to P is equal to 0.1. Maybe if you are called 10 times, maybe 5th time itself a success, that is different, but 1 call may be success. So there will be a expectation, there is a 9 call will be a fail. So that is expectation. Now you see what is the probability of S less than 8. So we have to calculate each terms you have to calculate. So probability of S is equal to 0. What is the probability of S is equal to 0? We can take a probability of X is equal to 0. We can substitute here. Probability of X is equal to P into 1 minus P raised to 0. Instead of Y here I am taking the 0. So it is a 1 minus P 0 plus P into 1 minus P raised to 1 plus P into 1 minus P raised to 2 up to the P into 1 minus P raised to 7. 0 to 8. 7. So what is my P is equal to 0.1? We can write like that. 0.1 plus 1 minus P, 0 is gone. 0.1 into 0.9 plus 0.1 into 0.9 square plus 0.1 into 0.9 cube up to 0.1 into 0.9 raised to 7. So this is a geometric progression. You see, this is a sum of the geometric progression. This is 1, this is 0.9 is multiplied here, again 0.9. So it is a geometric progression. Sum is equal to geometric progression. Then we can write A into 1 minus R raised to N divided by 1 minus R. This is a geometric distribution. Here A is equal to 0.1 and R is equal to 0.9. And n is a number of terms. N is a number of terms. 1, 2, 3, 4, it is up to 8 terms is there. So we can substitute here is equal to 0.1, 1 minus 0.9 raised to 8. 8 terms are there. 1 minus 0.9. So this is approximately 0.5695 something it will get. So that is a geometric distribution. We have defined the two ways. Alternative way, we defined the number of trials of failure. We have to check this before the first success means these trials are failed. Number of trials on which the first success means last trial is success. Here we are expressing number of trials of failure before the first success. So this all y is equal to failed success. Failure, failed only. So we have to give the y in top and y. So this way we have find out the equation and we find out what is the value of probability s less than 8. So this is just a basic of the geometric distribution. We understood what is the before the first success and on which the first success. Thank you.